Hi everybody, today we're going to be talking about prime factorization, and this goes with the learning goal. I can use factors and multiples to find GCF, LCM, and prime factorization. So there are some vocabulary terms that we need to go over, quite a few for this lesson. A multiple is the product of a given number and another number. So when I take a number and I multiply it by another number, I get a multiple. And the least common multiple is the smallest multiple that two or more numbers share. So for example, we might be asked to find the least common multiple of 6 and 9. And when we do that, we just start listing the multiples of 6 and 9 and find the smallest one that they share. So I'll start by listing the multiples of 6, and the way that I do that is just taking 6 times another number. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, and I could go on for a while. I think I'm going to stop there for 6, and then I will see if I need to list some more if I don't come to one that 9 has in common that's listed here. So I'm going to now start listing the multiples of 9, and 9 times 1 is 9, 9 times 2 is 18, 9 times, oh, I don't have to go anymore. I have 18 and 18. And that is the smallest number that those two numbers share. So 18 is the least common multiple, or LCM, of 6 and 9. Now, a factor is another term that people often confuse with multiples. So they get confused about what's a factor and what's a multiple. Multiple sounds like the word multiply. You have to take the number and multiply it by something else to get its multiple. Factor is a number that divides evenly into another whole number, and I'll be giving some examples of that in just a moment. Prime number is a number that only has two factors, 1 and itself, and the smallest prime number there is 2, because it only has a factor of 1 and 2. Those are the only numbers that divide evenly into 2. 2 is also the only even prime number that there is, because any other even number is divisible by 2, and so it's not prime. A composite number is a number with more than 2 factors. So any number that has more than just 1 in itself would be composite. So here we have a couple numbers, and we need to determine if they are prime or composite. And we'll start with 12. We need to decide, does it have any factors other than 1 and itself? And so what you just need to ask yourself is, what are numbers that divide evenly into 12? And I'm just going to go ahead and list those. So we know that 1 and 12 will divide evenly into 12, because that's the case for every number. However, 12 is also even, so that tells me, because it ends in a 0, 2, 4, 6, or 8, that tells me that it's divisible by 2, and I know that 2 times 6 is 12. And then I would ask myself, well, does 3 go into 12? And you can look at this a couple of two ways. You might know that 3 does divide evenly into 12, or I can add those two digits together. 1 plus 2 is 3. 3 is evenly divisible by 3, therefore the whole number is evenly divisible by 3. And 3 would be multiplied by 4 to get 12. Now at this point, there are no numbers in between 3 and 4. And so I know that I've now listed all the factors of 12. And you can easily see that it is not prime. It's going to be composite, because it has factors other than just 1 in itself. Now if I look at 13, again, I know that 13 is divisible by 1 and 13. It's not divisible by 2 because it's not even. If I add up the digits 1 plus 3, I get 4. 4 is not divisible by 3, therefore 13 is not divisible by 3. It's not divisible by 5 because it doesn't end in a 5 or a 0. It's not divisible by 6 because it's not evenly divisible by 2 and 3. It's not divisible by 7 because I know that 7 times 1 is 7 and 7 times 2 is 14. It's not divisible by 8 or 9. It's not divisible by 10 because it doesn't end in a 0, and it can't be divisible by 11 or 12. So 13 does only have two factors, 1 and 13, and therefore 13 is prime. Now sometimes we're asked to give the prime factorization of a number, and that's a little bit different than listing the factors. The prime factorization is a list of prime numbers that when you multiply them together you get, in this case, 60. And the way that we usually do that is with a factor tree. So I would start with 60 at the top, and then I'm going to just list two factors of 60. And usually what I do is I look, and if the number is even, I'm going to start with 2. I know that 2 times 30 equals 60. And 2 is prime. So I'm done with this part over here because I'm trying to list all the prime numbers that multiply together to get 60. So now I'm going to start dividing up 30. Well, 30 is also divisible by 2. So I could say, well, 2 goes into 30 15 times. And you don't have to use 2. You can do something different. I could have also done 3 and 10, and this would have worked out fine as well. Again, 2 is prime, so I'm done with that. And now I'm going to look for factors of 15. Now, a lot of times people are tempted to say that any odd number is prime, but 15 is not prime. I know that it ends in a 5, so that means 5 divides evenly into 15, and 5 times 3 is 15. So now I have to ask myself, are these two numbers prime? And 5 is prime, and so is 3. And so this is my prime factorization, and the way I would write that is just 2 times 2 times 3 times 5. And I just list those off, usually in order. And you can see, if I actually did multiply those together again, 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 is 60. So this does equal 60. Which is what I wanted, and these numbers are all prime. And that's actually the only numbers that would be the prime factorization of 60. No matter how I do my factor tree, I'll come up with those 4 numbers. Here's some more vocabulary. The greatest common factor of 2 numbers or more numbers is the largest factor that 2 or more numbers share. So in this case, I'm asking you to find the greatest common factor of 40 and 32. And there's 2 ways I can do that. One involves just listing the factors of 40 and 32. So I'm going to start by just listing the factors of 40. And now I'm going to list my factors of 32. I'm going to write 1 and 32. And then I can see that 32 is even, so that means that 32 is divisible by 2. And 2 goes into 32 16 times. 3 plus 2 is 5. 5 is not divisible by 3, so that means 32 is not divisible by 3, but it is divisible by 4, and 4 goes into 32 8 times. 32 does not end in a 5 or a 0, so it's not divisible by 5. It's not divisible by 6 or 7, and then I get to 8, so I'm done. So I can see that there are lots of common factors here. 1 and 2 and 4 and 8. And so I look for the largest one, and that would be 8. So the greatest common factor of 40 and 32 would be 8. Now the other way to find greatest common factor is kind of neat. You list the prime factorizations of both 40 and 32. So I'm going to make some little factor trees over here. Let's start with 40. And I'm going to ask myself, well, what numbers divide evenly into 40? And maybe I decide I want to start with 5 and 8. Again, it doesn't matter what 2 factors you list there. Just any 2 numbers that when you multiply them together, you get 40. And 5 is prime, so I'm done with that. So now I'm looking for factors of 8, and I know that 8 is evenly divisible by 2 and 4. 2 is prime, and 4 is evenly divisible by 2 and 2. And those are both prime. So I'm done listing the prime factorization of 40. And now I'm going to do the same thing for 32. So I have 2, 2, 2, 2, 2. There are 5 2's there. Now what I'm going to do is circle all the factors, all the prime factors that these 2 numbers share. So they both have a 2, they both have another 2, and they both have another 2. And what I'm going to do now is just multiply those numbers that they share, those prime factors that they share together. 2 times 2 times 2 is 8. And that gives me a GCF of 8, which is just what I found with the other method. But if you're not someone who likes listing the factors of a number, sometimes this prime factorization method can work better, especially if you're dealing with larger numbers and you don't want to have to list out all the factors. And here are your free response and multiple choice questions. So go ahead and pause the video now and answer those 2 questions.